set up with a bare bulb, and it's about almost 2 meters probably away from the screen. So, you see that? I'm pretty close. And then I'll pull back. So I'm moving my lens closer to the light. Remind you of anything? I'm going to try a different lens. This one has a little shorter focal length. I'm going to push the light closer to the screen, about just over a meter, I think. I'll start up. It looks pretty good to me. Pull it back a little farther. That's about as good as I'm getting here. Keep in mind, these aren't the most expensive lenses, which means you're never going to get a perfect image, but it's pretty good, pretty cool. All right, I've changed the light bulb. Here, what do you think? Recognize it? The lens I'm using has a focal length about 15 centimeters, and I have the light at about a meter. There's the second one. Now I'm going to switch to a different lens. It's about 30 centimeter focal length. I'm going to move the light. You don't have to move the light, you'll just see it works better. Just play around again. I can't stress that enough to just experiment. There's one. I'm about 50 centimeters from the screen. And there's another one. And I'm about, over a meter. Probably a meter and a half, not quite. And it really helps if you hold the lens at about the same height as the bulb or candle or whatever you're using. And the room doesn't have to be dark. It's not very dark in here. Just dim. I have the lights off. The shades closed. So. We'll take a look at a couple of lenses here. This one is a concave lens. It's thick on the outside and skinny on the inside. It's concave, and this is convex, very, very thin convex. Okay. So put them together. Let's see what we see. Just play with them. Get a sense of what you can see here. Let's try this one. There we go. Getting a little more magnification. Okay, so I have two convex lenses. And I should be able to see. Can you see that they're upside down? If I only use one, it's pretty blurry. The second one can bring it into focus. Then if I switch them, it works too. I get more magnification with this orientation than the other one. The one in my right hand, this one, has a focal length of 10. This one has a focal length of 18, and that's centimeters. Now I've got both the same. These both have 18. I can get this one. There we go. So switching them won't affect anything since they're the same. Cool. So if we focus on something far away, like this bookshelf, and then bring something into our near vision, like this page, can you see that one is in focus and one is not? If I then focus on the near, and then still have the far in my vision, can you see how the near is in focus and the far is not? This is a lot like what it's like to have these kinds of different vision issues. So this one is called nearsighted. The person who's nearsighted can see everything nearby, but cannot see well in the far, and vice versa, farsighted. They see fine far away, but when they try to put something close up, it's blurry. So you can't just put on somebody else's glasses and get a feel for what their vision issues are. This is much more accurate way of getting a feel for that. Okay, for this part you need to borrow a couple pair of glasses, and they need to be different. You need to have a pair from somebody who is nearsighted, which means they need them for distances, and a pair of reading glasses, or a person who is farsighted. And if they're progressives, it's fine. If that means they're bifocals, they have multifocal, it'll still work. These first pair are like that, and you'll still see it works fine. So put them kind of at arm's length, and the question I have for you is the image upright or upside down? Pay attention to the fence. Okay, that's the first pair. And here's the second pair. These are the reading glasses. Not as clear, it's a little more blurry. Upside down, right side up. Can you see? That's the greenery, but then look at here. There's the fence, and that's the top of the fence, middle, and now the snow.